Hello, guys. Greetings to every one of you, and welcome to today's lesson with Sir Godwill Yakum. This is lesson number 5. We shall be looking at the topic forces. Yes, so I believe if you are attentive, you will learn a lot. What is a force? A force is a push or a pull of one body on another. Straight to the point, we look at the type of forces. We have two types of forces: contact forces and non-contact forces. Contact forces, these are forces that act between bodies which are physically touching each other. When forces act between bodies which are not in contact, we talk of non-contact forces. Forces that act on bodies only when they are physically touching each other, we call them contact forces. We have them in numbers. For example, friction, normal reaction force. These are contact forces because they act between bodies only when they touch each other. Other forces like the gravitational force, electrostatic force, are forces that act on bodies even when they are not touching. Consequently, we will now look at some examples of forces. We have the gravitational force, electrostatic force or electric force. We have the air resistant force. Air resistant force, which is also known as the drag force. Then we have upthrust. Upthrust is also known as the buoyancy force. Then frictional force and viscous forces. These are some examples of forces. Yes, so now we'll just look at some of them a bit more detailedly. We want to start with gravitational force. The gravitational force is a force that a body experiences due to its mass. So, by virtue of its mass, a body might be subjected, of course, it's not might, a body is subjected to a certain force known as the gravitational force by virtue of its mass. Okay, that force, which is the gravitational force, is given by the mass times the gravitational pull, which is or acceleration due to gravity. So that is what you see right now on your screen. F equal to what? Mg. This force is known as the weight of the body. All right. So now, ladies and gentlemen, we are on Earth. As a result, it's important to also mention that on Earth, the gravitational acceleration is 9.8 meters per second squared. So as a result, a body of mass 5 kilogram will have a weight of 5 times 9.8, and this weight will be given in Newton. Electric force. Electric force is a force that a body experiences due to its charge. Electric force will only exist between charged particles. A charged object will experience forces due to other charged objects nearby or near it. The behavior of the charged object in a uniform electric field is investigated in our further studies. So as we continue, we will look at the electric field, and that is where you will really understand the study of what charges. Now, the buoyancy force and also upthrust forces. This I would like you to know that bodies either totally or partially immersed in liquid or in fluid, they will experience a force known as an upthrust force due to the slightly different pressure exerted on their lower and upper surfaces. Since pressure in liquid increases with depth, so at the depth there is greater pressure than at the surface. So, due to this difference, there is a force known as the buoyancy force or the obtuse force, which is exerted on that object. As we continue, we'll look at that also detailing. Then we have the frictional force, which is a resistant force, a force that acts in opposite direction to the direction of velocity or motion of a body. All right. All right. So after mentioning this, it's important we can move ahead to the turning effect of forces. Talking about the turning effect of forces, we are talking about moment. What is the moment of a force? The moment of a force is defined as the product of that force times the distance. So the moment of a force is given by Fx. The force times the distance. Distance from the pivot. So the turning effect of a force, sometimes known as torque, is known as the moment at a point. When considering a single force, the point about which the force is producing its moment effect must be specified. The moment of a force about a point is equal to the force multiplied by the perpendicular distance of the line of action of the force from a particular point, which sometimes is referred to as the pivot. Some people call it pivot. I want you to underline some parts of this definition here. The first thing is perpendicular distance from a point. So it is not just force times distance. The moment is not only force times distance. This distance here must be perpendicular, and this distance is taken from a point, from a particular point. Okay, so good. You can see an example here. Okay, so this is an example. This is a spanner. So the question I will ask you is that I want to hold this spanner. I want to use it to untie this screw. So now the question is, somebody holds it at this point, and then another person with a similar spanner holds it at this point. I want to know who will have to apply less force for greater output. Is obviously this one, because the turning effect of forces or the moment is proportional to the force and the distance. See, the distance is short here. That is why the person needs to apply a lot of force. The distance is already up to 25 centimeter here, which is more than this one by 2 and so on. So a lesser force will be applied for this to cause a turning. That is why when you look at the door of your house, if at all you live in a house, there is what we call the hinge. The hinge is where the door is attached to the wall. So this can be a hinge here. Good. So at this now here, this is where you open your door. So when you open here now, the door turns about this point. This point like that is being fixed on the wall. Then this place will turn like this. So good. Now the question that begs for an answer is, why is it that when you put your door, this is the hinge, why is it that you don't come and put the handle here so that you push here to open? The truth is that you use a lot of force to open here, but when it is here, just a slight push, the door moves. Those are some application of what? The moment of a force. A minute. All right, thank you. All right, the moment of a couple. Now it's important we look at the talk of a couple. And I'll first of all want you to understand what a couple is. Then we'll talk about what it means by the moment of a couple. Now, a couple actually is produced when two parallel forces, equal magnitude, acting in opposite direction and have uh, different line of actions. When these forces they coincide, they form what we call a couple. I repeat, these two forces have equal magnitude. That's the first thing. Second thing, they are in opposite direction. They are in opposite direction. And then number three, they have different line of action. What happened now is that they form a couple. So that's good. That's good. You have understood. That's good. Now you apply a couple where you turn a tap like this. When you turn a tap, you are applying a couple. You are applying forces. You are applying two forces in two different directions, and these two forces are equal in two different directions, in fact in opposite direction, having different line of action. That's a couple. Okay, so that's good. So anytime you're opening a tab or closing a tab, you're applying a couple. Now when we are considering the moment of a couple, we do not need to worry about the specific point that the moment is produced about, meaning that the pivot. The moment is the same, whatever the point that we choose. The moment of a couple is equal to the sum of the moments about any point of the two forces. Now remember that moment is force times perpendicular distance from the pivot. Good. So now all right. Okay guys, so now the moment of a couple is equal to the magnitude of one of the forces times the perpendicular distance between the line of action of the forces.